This podcast is to help review for an upcoming quiz on Chapter 4. The focus will be the electromagnetic spectrum, the relationship between wavelength, frequency, and energy, excited and ground state electrons, and electron configurations. To go back and review some things, we talked about the relationship in the electromagnetic spectrum between frequency, wavelength, and energy. This relationship, as summarized here, talks about the fact that energy and frequency are directly related, whereas wavelength and frequency and wavelength and energy are inversely related. The table you see summarizes some of the symbols and the units that we will use on your quiz. You do not have to know these two equations, nor do you need to have memorized the constants. For the upcoming test, yes, you will have to memorize the equations, but never will I ask you to memorize constants. A typical calculation might be asking you to calculate the energy of ultraviolet light, given that that light has a wavelength of 125 nanometers. Now, I've skipped over a number of slides on the smartboard notes, so if seems like it's jumping a lot, you might want to go back to your Edline and upload these notes and kind of look at them in their entirety. But right now I'm just giving you a little bit of an overview and review for the quiz. So let's say that we're going in the direction of starting at wavelength to 125 nanometers and going to the energy. The game plan, as you see outlined, is to convert nanometers to meters, then calculate frequency, and then finally to calculate energy. One of the things that you will need to know is a conversion factor between meters and nanometers. Setting it up using dimensional analysis, I come up with a wavelength 1.25 times 10 to the minus 7 meters. That seems very short. Yes, it is. Ultraviolet light is high energy light, so its wavelength will be extremely short, unlike radio waves and microwaves, etc., which are much longer than ultraviolet light. Next, we calculate frequency using the equation that you'll be given on the quiz. So just knowing what the units stand for, C stands for the speed of light. That is the constant given here, 3.00 times 10 to the 8th, equals, we insert the value for wavelength that we've calculated above into the equation and solve for frequency. Isolating the variable will give you an answer of 2.40 times 10 to the 15th. If this is moving too fast, you can always pause the podcast, do the calculation yourself, and I would encourage you to do that along the way. Finally, taking the frequency that we have calculated and inserting it into the energy equation, doing the math and calculating, we come up with the final answer of 1.30 times 10 to the minus 8 joules. Not much energy, but the point here is, can you do the calculation at this point? Analyzing the energy and figuring out what its applicability is not the focus of this review. Now, you turned in a packet today and you may have colored in the bright line spectrum for hydrogen. You saw this bright line spectrum for hydrogen in class about a week ago, and we looked at these lines and we saw these 4 different colored lines, but what was causing these lines, we'll talk about that in a few minutes, but this idea of calculating the energy, the frequency, and the wavelength, that's the first part of my review for your quiz. So I have another table for you to complete. Notice that there are question marks. Your job is to pause this podcast and use the equations given, use the constants given, and see if you can calculate the answer to where the question marks are. Now would be a good time to pause the podcast, get out the calculator, look up the constants and the equations, and see if you can do it. after you've finished doing the calculations, then restart the podcast and go on to the next slide. Here are the answers. I hope you were successful. This concludes the part of the calculation review for energy, frequency, and wavelength. Now on to excited electrons. I'm excited. You may not have seen this part of the smartboard notes, but I wanted to review with you what they looked like, talking about energy levels of electrons, ground state. You know that we talked about the shelves in the back of my room and energy levels and excited electrons, but I want to give you a little visual of what is available to you on my smartboard notes. Remember, I talked about how chemistry is often good for life lessons, and the life lesson in this unit is that the first step is the biggest. That's true for energy levels as well. Going from the ground state to an excited state, I would have to absorb energy. And if I jumped back down, I would give off that energy. So these stairs represent energy levels. And so hydrogen, having only one electron, by my smiley face in here, has the ability of going from the ground state, the lowest energy state, to a variety of energy levels. In moving farther away from the nucleus, the electron has to absorb energy. We would call that a quantum of energy being absorbed. And if it did that, it would move to an excited state, as shown by the diagram here, absorbing a certain quantum of energy. When the electron leaves this unstable state, this excited state, it quickly jumps back down to its ground state and gives off a quantum of energy. But if we look at this amount of energy given off, if we visualize its light, its wavelength, then we can say it gives off light, and that would be called a photon. Remember that with light we can look at it in two ways, both photon and quantum. Take a moment and review these questions. You'll see something fairly similar on your quiz about electrons becoming excited, absorbing energy, emitting energy. Do you have the ability to answer these correctly? Pause the podcast now, see if you can answer them. Here are the answers. Evaluate your understanding of the chapter. If you weren't very successful here, now would be a good time to pause and go back and review in detail the smartboard notes that you can find on Edline. The next part of this podcast, we're going to review a little bit about electron configurations, the fact that you viewed a wonderful video that illuminated the difference between energy levels, sublevels, and orbitals. Don't forget that you can always go to Edline and view that link again at any time. Remember that we talked about the fact that the energy levels are not evenly spaced in energy, that the number of electrons in a given energy level can be calculated using the equation 2n squared, where n represents an energy level. Since these energy levels contain a lot of electrons, these electrons, which tend to repel one another, have to have their own little space, their region in space where two electrons can go. So it turns out the number of orbitals is exactly 1/2 the number of electrons in a given energy level. So the first energy level only has one orbital, the second has two orbitals, 9, and so forth. And when we put two electrons in an orbital, they actually have to be spinning in opposite directions. And these are two ways that we can show spinning. When we think about the spinning of electrons, it's really that they're spinning on their axis, spinning clockwise or counterclockwise, but the up and down arrow is a notation that we will use later on. Let's take a moment to review some of the things that you viewed in the podcast. First of all, we have sublevels, and they're called S, P, D, and F. How many orbitals do S sublevels have? How many orbitals do P, D, and F sublevels have? Hopefully you remember that the number of orbitals are the odd numbers 1, 3, 5, and 7. There is one S. There in the S sublevel, there's one orbital. In the P sublevel, 3, etc. And how many electrons go in an orbital? 2 electrons in an orbital, so the first sublevel can have 2 electrons. The p sublevel can have a total of 6 electrons, d's 10s, and f's 14. A little bit more review. How many sublevels are in the 4th energy level, etc. Read through these questions, pause, write down your answers. Pretend that this is your quiz. Hopefully you took the time to stop the podcast, write down your answers, and check to see if you are correct. Writing electron configurations parallels our Bohr diagram, and we spent time in class going through that. So make sure that you are familiar with the first 20 elements, 1 through 20 up through calcium, and then after that it gets a little complicated, and that's what I want to spend the rest of the time on. If you notice, the electron configuration for potassium ends with 4s1. Some of you might be thinking, well, wait a minute, I thought the 3rd energy level had 18 electrons. There's only 8 in there so far. How come the 4s is being filled up? Well, we go back and we're using the periodic table. We notice that the potassium is found in the 4th row of the periodic table, and the electron configurations are best written by just simply reading the periodic table. Don't go with that diagonal roll. That seems to cause more trouble than it's worth. Just knowing the position of calcium, it's in the 4th row, it's in the S block, it's the 2nd element in, would give you the electron configuration for calcium. Going back to our energy level diagram, 1, 2s, 3, 2s, 2p, 3s, 3p. Yes, there's 3d there, but notice something here. The 4s sublevel actually is lower in energy than the 3p, or excuse me, than the 3d. So what that means is the 4s will fill up before the 3d sublevel. When you look at this energy level diagram with all of the sublevels and the overlevels, it becomes way too complicated. So that's why we moved to using the periodic table, the tool that you will always have for tests and quizzes. Notice how I have numbered the energy levels going down the periodic table, but also in this area I have numbered the D's a little differently. Notice that the number that precedes the D block is 1 less than the row that it is in. So when you're writing electron configurations and you're going through this block here, this is not the 4D, but the 3D. But then the numbers pick back up again, same as the row that they're in. This is the 4P. So this is the 3P. This row is the 6P. This is the 5D row. So make sure when you're writing your electron configurations, you know that the D block, the number that precedes the D, is 1 less than the energy level, the period, for the element. So give it a go. Try to write the electron configurations for these 4 elements. Pause the podcast, and then we'll come back on to wrap it up in just a moment. So here we go. Take time to check, to look at the large numbers, which represent the energy levels, the letters that represent the sublevels, the superscripts. Remember that S's can have no more than 2 electrons, P's no more than 6, D's no more than 10 electrons. I want to call something to your attention as you're going over this. Notice that if you look at the periodic table, manganese and technetium are right above or below one another in the periodic table. And notice the similarities and how their electron configurations end. One would expect that when you're looking at 2 elements that are in essentially the same family. I hope this podcast has helped you, and feel free to bring in a few questions to the start of class tomorrow, but then we're going to be moving right on ahead. Thanks.